Hey guys, so it's time for crazy sinusoidal graphs. Now I said sinusoidal because that refers to sine and cosine. So let's get right to it. So what you're seeing right now is an animated version of a bunch of different possibilities for a sine function. All right, moving it up or down, stretching it vertically, as well as stretching it horizontally. The only thing that is not included right here is a horizontal shift, which you will study in pre-calculus. So getting right to it. Let's see. Let me pause these. All right. So one example at a time. Let's go with 2 sine of 3x minus 1. All right. So a couple of things that you need to notice about 2 sine of 3x minus 1 graphed on this radian scale. All right. Your main objective is, what does the 2 do? What does the 3 do? And what does the negative 1 do? Well, if you read through your notes and have a basic level of understandings, you know that a sinusoidal function starts at its midline, right? So I'm going to think of the point of origin, the original point, the starting value, to be 0, -1 right here. All right. So again, a sinusoidal function starts at its midline. The midline is determined by the c value. All right. If we think of this as a sine of bx plus c, that number that is being added or subtracted to the entire sine function or cosine function is the midline. All right. And to show that, I'm going to graph y equals -1 right here. All right. And I'm going to leave it as a dotted line. All right. So here we go. That's y equals -1. So you can now see the effect of the -1. All right. You can also see that it's a sine function because it starts at the midline. If this were a cosine function, it would start at its peak. All right. So here's cosine. All right. Same midline, but you now notice that the y-intercept is at a peak. All right. At a maximum. All right. But let's go back to 2 sine. So we're learning several items right here. So 2 sine. We've determined that -1 is the midline. Now, if you look at the value 2, 2 is called the amplitude. 2 is sort of like, how tall is this wave? How tall is the wave? Well, to measure how tall a wave is, you have to go off of sea level. All right. So imagine midline as sea level, right? Waves dip or rise above it and dip below it. All right. So this wave from -1 will go as high as +1. In other words, that's a gap of 2. Also notice from the midline, which is at -1, you have a lowest output of -3. Again, a distance of 2. So the number 2, the number 2 determines the amplitude. It means that this wave is going to be 2 units high. In other words, you can picture a line at y equals 1 and a line at y equals -3 and sort of use those as guidelines. Right? Those are like guidelines for the way that I graph this function. All right. So now hopefully you see the meaning of the 2 and the -1. The last item to understand is the 3. What in the world does that 3 do? Well, in order to understand what 3 does, maybe try a 2 or try the original 1. All right. The original 1 tells you, like you have in your notes, that the standard length of a period for a sinusoidal function is 2 pi. Look how I start at 0, -1, and look how I end one cycle. I'll trace. Look how I finish one full complete cycle, redundant, at 2 pi -1. All right. Now I'm back where I started. It took a span of 2 pi radians, or 360 degrees, 2 pi radians for me to get there. Okay. Well, look at what happens when I change this to a 2. Now my cycle has gone from starting at 1 to ending at pi. So it's half the size. Think of it as a horizontal compression, right? This is the function is now twice as frequent. Well, if I make it 3 times as frequent, instead of having one period in a span of 0 to 2 pi, I now have 1, 2, 3 periods in a span of 0 to 2 pi. So this 3 means a couple of different things. Number 1, it means you now have 3 periods between 0 and 2 pi. 3 periods between 0 and 2 pi, which makes each one, well, 2 pi divided by 3, 2 pi cut into 3 parts, is really just 2 pi divided by 3. In degrees, that is 120 degrees, or 360 cut into 3 is 120 degrees. All right. So now we should have a full understanding of why 2 sine of 3x minus 1 behaves the way it does. The only thing that we didn't talk about is, what if it's negative? You flip. That's the only thing. Okay. So that explains all the 3 basic transformations of a sinusoidal function. Cosine behaves the same way, just has a different initial value. Those are the three transformations. Let's go.